Hi, this is Rina Lee from Daegu International School and Peer Tutoring Club. We are starting another new section, which is 1-3. It is called Limits at Infinity. So let's get started. So, the definition. The meaning of limit at infinity means that, take a look at here, limits of x towards infinity of function or limits of x towards negative infinity of the function. Remember how these equation looks like. So there are two types of function. One is polynomial and then two is rational. For polynomial function, it is very simple. It is just any behavior of a graph. So it is something like if there's a graph over here, and then there's a graph over here, which is called fx, then if you're looking for limits of infinity of this function, then we are looking for the endpoint over here. Because this is positive infinity, and then x is toward positive infinity, which is over this direction. Therefore, since this is going to a little bit like 0, going towards a 0, then the answer for this should be 0. And then for limits going towards negative infinity of a function should be infinity, because looking at this direction and we don't know where it will end. It is just infinity. It will go forever. Therefore, it should be infinity, and this should be 0. This is how it means by the end behavior of the graph. The end behavior. So for the rational function, there are a few things that you need to memorize. It is their rules. It is horizontal asymptote or slant asymptote, which is known that, take a look at this. If there's a function, there's numerator and denominator, like here. There's a function numerator and denominator, and then they looks like this. If you're confused, then I'll give you some example. This means that there's a random number, such as 2x, and then there's a power. It could be just 4, and then there's more functions like plus 3x3 or minus 3, something like this. It should be over another random number of the x of the power. For here, this power should be anything like 5 or 4 or 3, and then there will be another number like this, something like this. The number, the factor that you have to pay attention to is not these. It is the power. So there's 3 rules. First is if m is less than n, m is here and n is here. If m is less than n, and then it is known that the function should be 0. Number 2, if m equals to n, then the answer should be a over b, which is the initial number attached to the function. In this case, a and b should be 2 and 4. And then mn should be 4 and 4, because it should be equal. 3, if m is greater than n, then it should be infinity or negative infinity, and it depends on which way the function is limited to. And then this is really important, that you have to know that k, it is just a random number, k, and then log x, and then x to the nth power, and then b to the x power to the x factorial towards x to the x power. This is a list of functions by how fast they grow for a large x in increasing order. You have to know this. So, the example questions. By looking at this, you'll know this is equals to infinity. Because by plugging in infinity towards the x, you know that infinity of 6 powers is still infinity. So it is infinity. Second, limits. This time is different. It is negative infinity, even though they have the same function. If you plug in negative infinity and then 6 power, then you know that it is still infinity because it is 6 power. It is not an odd number. And then if you do this, then you'll still get infinity. If this function is at 4x to the 5th power, then it will be different. It will be negative infinity. Number 3. Limit x towards infinity of the function e to negative x power. To answer this, you better have to know how this function's graph looks like. It looks like this. There's x and then y, and then it looks like this. By looking at this graph right over here, we can see that for number 3, it is 0, because you better have to look at the end behavior of this function, and we know that it is heading to 0. Same with here. We're looking for negative infinity of the function, which is here, and we know that it is infinity. It is endlessly going up and up and up. Therefore, it is infinity. Number 5. We have to apply the rules for a rational function over here. And then we can see that the power of numerator is greater than the denominator's power. Therefore, we can see that this equals infinity. Number 6. We can see that the power are equal for for both numerator and denominator. Therefore, we can see that this equals to 9/8 using the initial number of each functions. And for the last question, we can see that the numerator's power is smaller than the denominator's power. Therefore, we can see that this equals 0. This applies the first rule of rational function, and this applies the second rule of rational function, and this one applies the last one, number 3, of the function. This is it for today's lesson, and thank you for watching.